Human nature is to desire certainty as a doctor as much as anything, because you want to give that patient comfort and to know what's happening. So it's great to imagine, especially with technology, that you can have that certainty and that you have a positive test result. That means you have the disease. Or you have a negative test result and you don't have the disease. In 2015, there was a big report that came out of the National Academy of Medicine that defined the term diagnostic error. And so this was trying to bring a lot of different ideas together to talk about when a patient either has a diagnosis missed or has a wrong diagnosis. Either of these, of course, being problems in that the patient won't be treated correctly with the wrong or missing a diagnosis. They estimate that up to $100 billion a year is lost due to diagnostic error in healthcare.
The first problem is that most people, and clinicians included, look at the result of a test and they think that that's the answer. But that's not necessarily the answer. Positive test result doesn't mean the person necessarily has the disease. That is a basic aspect of diagnosis and test interpretation that a lot of people miss or forget about.
I mean, sometimes when you look at like things where the disease incidence is low or maybe the test isn't as good, and then you realize it doesn't really matter if the test was positive or negative, it didn't actually like move the bar that much.
I was pretty impressed with the work that Dan was doing, especially from, reading his op-ed in the Washington Post. One of the things that really stood out to me right away was testing for breast cancer. There's often misdiagnosis for this, really serious condition, and that often women would go through this treatment without actually having breast cancer, and that just really kind of hit home for me.
I teach medical students how to do diagnosis. It's part of an epidemiology curriculum, and they're taught basically a math formula for how to figure out, if you use a test on somebody, how likely is that person to have disease.
As a person who develops and validates these tests, I want and like a provider to know that there is some variability in our ability to say definitively this is positive, definitively this is negative. We have false positives, false negatives. They could be due to any number of factors, interferences in the test. So if you have a 90% specificity rate, there's a possibility that 10% of the time you're going to get the answer wrong.
Somebody back in the 70s at the Harvard hospitals created a little scenario where they asked doctors basically the same question. They walked around and asked doctors, if you have a test, it's very accurate in terms of the numbers we use, but you try to test for a disease that has 1 in 1,000 people will have that disease. You get a positive result. How likely is it to be accurate? And the true number was 5%. The vast majority of people answered 95% or higher. So, doctors who are in practice at one of the most famous institutions in the country were just very wrong at this basic aspect of diagnosis.
I was hired to do the enrollment, so we went not door to door, but clinic to clinic, hospital to hospital, doing surveys, surveying doctors, and testing how they make decisions.
I mean, after we had over 500 doctors enrolled, in 2 years of chasing them down to get these numbers, we found what we suspected.
Doctors were not great at interpreting tests or deciding when to use diagnostic testing, which Dan already had a feeling that was the case. So we started from the research study to the diagnostic tools. And then when we started developing the diagnostic tools, we asked some medical students what they thought and identified some knowledge gaps from there.
Dan received a very prestigious NIH award called the NIH Directors Award, and he invited me to be a part of this research early on.
One Friday afternoon, I think I was leaving the climbing gym, and I got an email, and the email said, "Congratulations, your grant's funded."
Did I think that Dan was going to get the NIH Directors Innovator Award? No. Nobody gets those awards. They are so prestigious, and they only give them to a very small and select group of people. From a psychological perspective, games are really important for learning because they can provide an opportunity for hopefully fun repetition. And that repetition can train a person to make accurate judgments much more quickly than they would otherwise.
We thought maybe that kind of sounds like something we wouldn't be able to do. Maybe we're not game people.
But I like to figure things out. I'm a problem solver. After I made the prototype, we shared it with Laura, and she provided some feedback. We made some little tweaks, and then we decided, yeah, this could actually work. It's kind of cool. Let's see if we can actually get it made into a real game.
I remember one meeting at the Code in the Schools headquarters, and we just basically kind of went over what some of the current issues in the game were and things we could fix. And I kind of just jumped in and started working on it.
One of the first things that we realized was going to be difficult about developing this game is that these clinical judgments are hard. They're pretty difficult. So we had our prototype version of the game and we sent it out to some clinician friends for testing. And they all came back to us and they said, this is way too hard. I can't do it. I can't get the answers right.
We're really trying to make this concept of medical testing fun so that people could learn at the same time. And fun and learning don't always go together.
Both my colleague and I just saw a real opportunity to get in there and apply some of the visual system that we developed to the game. I thought it made a lot of sense to try and teach people to do something that's very scientific and logical in a more intuitive way.
The lay public talks about intuition as being like a gut feeling that just comes from an amorphous place. Intuition from this perspective of psychology is more like your automatic reaction. And in this case, it would be your automatic interpretation of a test result. Well, a really helpful analogy is driving a car. When you first start driving a car, it's difficult. You have to think through every step. The more you drive a car, the more every single one of those motions becomes more automatic and thus easier. The reason why that's important is because clinicians are almost never practicing medicine in circumstances where they have a lot of time to stop and think.
Game development is a way to kind of crash together logic and art and creativity into one job.
We had already done kind of a lot of the visual research earlier on, so we had a lot of the visual styles and things like that. But we did look a lot at precedent games or just educational tools. It's not even necessarily games.
Dan and everyone involved really cares about getting it right, from the wording to the visuals to the feedback that we're giving. So it isn't just throw something over the wall. It is make an iteration. See what people's response to that is. Make another iteration. See what their response to that is.
A lot of people probably think that development of games and things takes a long time, but it's actually that's how it works, because you have to iterate on a concept over and over again until you really get it right, and that just takes a while.
It's just really cool to work on a project where we might, at the end of the day, make a difference in the world and change the way that people practice medicine. I keep throwing it out there as a possibility because it excites me, but the possibility of actually making a game that saves lives, I find pretty thrilling.
Playing the Bird game was a humbling experience at first. I really wanted to use logic and math, so I was glad to have a second pass, and after reading some of the tips for success, I was able to let go of a little bit of my desire to have an exact, accurate answer and get sort of an approximation, and that was a much better tactic for playing the game.
What I love about the Bird game is that it very quickly walks you through a number of examples where you can very quickly begin to get a sense of how sensitivity, specificity, and the pretest probability, all these things interact to lead you to the correct interpretation of the test results.
When I first walked into the Bird game, I was kind of trying to figure out what was going on, but as I was progressing through it, I actually really enjoyed it, just because I've never really been introduced to the whole idea of pretest probability.
Considering how the game has affected my gut reaction and to trust that gut feeling or not, that's a work in progress, I would say. I think I probably would need to dedicate regular sessions with the game, because I find myself initially kind of going against my gut within the game, and then the game reminds me that it's okay to trust the gut. That I think is an important aspect of the game's purpose, at least for me, is to ingrain that.
And additionally, I found myself wanting to go back to the game and wanting to kind of play around, wanting to kind of learn more, wanting to realize how each factor interplays and how that boils down to, do I order this test, or what do I do if the test is positive? So I think it'll be really useful for everybody to kind of get that big picture idea of, are we ordering this because we're going to order everything, or are we ordering this with purpose?
The game helps you realize that tests aren't always as useful as you think they're going to be. Again, I think you're kind of searching for someone to just give you the 100%, like, this is what's going on, and tests are helpful, but they don't do that. So sometimes if you already have a really good indication of what you think is going on, or there's something that's extremely unlikely, when you look at this game, it helps you realize that the test isn't actually really helping you any further in that decision-making process.
We don't have big studies often to look at diagnostics. We don't have clinical trials to figure out how well they truly work. And so we have all these tests that are out there and that are like really complex in how they work, but how well they work in humans is, often kind of unknown.
We all take classes, pretty dry classes, to be honest, about basic statistics.
We talk about a lot of different topics when we're doing teaching. It's always nice to have a concise, clear, visually pleasing tool to use to emphasize a point, and that hits all the marks.
Even at the very best medical schools, I think we underteach diagnostic stewardship and the interpretation of test results. I think the Bird Game has enormous potential to improve the practice of medicine.